Okay, here we have a video about properties of density curves. The density curve below represents the number of minutes Joseph spent getting dressed for school each morning this past year. So here we have, even though it's density curves, this is a triangle. We can assume that it goes up and over and around. Remember, this is just the generalized look of a density curve data. We want to know a few things. We have to remember that the area of a density curve under a density curve, under or of a density curve, let me just say DC, is always 1. Okay, no matter what it looks like, it could be this big, it could be this big, it could look like a rectangle. It doesn't matter. The area under any density curve is always equal to 1. We went over left skewed, right skewed. We want to talk a little bit about the mean and the median. The mean, again, is the average amount from our data. The median is the middle value. In our case here, the median value this is always an approximated value here for any density curve. Median, we're going to assume, is right here. The mean would also be the same thing. The mean would also be, because we have between 3 and 7, halfway in between would be 5. So that is our mean. So our mean and median are actually equal to each other in this case. So we want to know which of the following statements is true. Check all that apply. So the distribution of time spent getting dressed is uniform. Now, in order for something to be uniform, it needs to be the same throughout the whole time spent getting dressed. So in our case, our density curve starts going up, it peaks, and then goes back down. It would have to be continuous all the way through at the same destination. So it would have to be kind of like a straight line going straight across here for it to be uniform. So we know that it is not uniform. The median time getting dressed is 4 minutes. We already determined that our median time is approximately 5, because that would be the middle value here. So it cannot be that. We're obviously assuming it's C, but let's just double check that. The height of the density curve is 0.5. Height, we have to know that the area of a triangle equals base times height divided by 2. We know that area of any density curve is 1, equals our base here is from 3 to 7, which is 4 units, times h divided by 2. Now we multiply both sides by 2. Okay, the right-hand side cancels out, and we get 2 equals 4h, divide by 4, and we get h is equal to 0.5. So that is true. Height is 0.5. Let's try one more question. Consider the density curve below. Here we have another density curve. We have a little bit of a right skew here because it tails down. We want a little bit about our median is approximately 3, I would say, because it's probably about the same on this side and that side. And our mean is probably the same thing. Would approximate right down the middle here. So here, the density curve, which statements are true? The density curve is left skewed. We know here that this is right skewed. So we know that A is incorrect. The mean of the density curve is greater than the median. The median, we could probably say that the median is right about here, maybe more like 2.75. So that could be true. The median of the density curve is 2. That we know is definitely false, because that would leave us right here for the median. So our answer must be B.